Hi, everyone. In this video, I'm going to talk about fairness criteria again, but this time we'll look at plurality with the elimination method and see which of the fairness criteria uh, it satisfies and which it doesn't. Much like the board account method, we'll see that many of these fairness criteria fail for this plurality with elimination method. However, one thing we can say right away with the plurality with elimination method is that the majority condition, or majority criterion, that will always be satisfied. And indeed, this is the same. This is for the same reason that the ordinary plurality method will satisfy the majority criterion, and namely that if when we look at the first place votes, we have a simple majority, plurality with elimination says that's the winner, just full stop. Because it uses the same, if we have a simple majority, we're done with plurality. Of first place votes, we're done with plurality. We don't have to, with plurality with elimination, we don't need to eliminate anyone, any candidates at that stage. So that's the last round that we need to execute. However, we've seen already in a prior video that the Condorcet candidate for, say, the math club example was C, and the plurality with elimination method gave us a different candidate in that case. It gave us candidate D, and so the Condorcet condition is not satisfied with the plurality with elimination method. Monotonicity is something we haven't taken a look at with regards to plurality with elimination. So I've given an example here. This is an example from the book, and let's talk through how this works. All right, so in this case, we're given the following preference schedule right here. And what we're going to do is we're going to look and see, count up the first place votes with this preference schedule. And we see that A receives a total of 9 first place votes, and that's written here. B received 8, and C received 10. And so since you don't have a simple majority in this case, or a majority of first place votes in this case, plurality with elimination tells you you have to eliminate the lowest vote getter from your schedule. So in this case, you eliminate B, and that's what's drawn here. Is I've just blacked out B in the preference schedule. It's a copy of the one above. And now you can count the first place votes, and A is still only getting these ballots in first place, whereas C now gets these 2 ballots in first place. So A has 9 votes still, and C absorbed all of the votes from B and has 18. So C is the winner in this example. So let's write that down. Well, I can write it here, but it's written here. So for this case, we have C wins. That's illustrated in green there. So now what does the monotonicity criterion say? The monotonicity criterion says, well, since C won with this method, if some ballots decided that they wanted to increase, if someone decided they wanted actually C to do better than they had done before, then C should still win. So what we've done here is we've taken these 2 ballots here and we've said, okay, well, these 2 people had a change of heart when they went to the election polls. They decided that they were going to actually make C do even better. C was second on their ballot before, but now C is first in their ballot. And then we go through the same plurality with elimination method with this new preference schedule. And don't be confused. You could just combine these 2 columns and make 12. They are the same ballots. but we're just keeping them separate to illustrate what's going on. So in this case now, we can do a count of the first place getters, and we have that A now gets only 7 of the votes, first place votes. B gets 8, and C now all of a sudden gets 12. And so now we still don't have a simple majority of votes. But now A, in this case, has the lowest number of first place votes. So we eliminate A. And when we eliminate A, we're left with this preference schedule. And we can count up that B is winning 15 votes, 7 plus 8, and C is winning 12. And so now, all of a sudden, just because 2 people changed their mind and decided to take the winner up, the winner has lost. And now B is the winner with this new preference schedule, with this new set of ballots. So this is something I think you would generally really not want to happen with a method. But sadly, with this particular method, you can't get around it. Oops, I think I... So the answer here is nope. Monotonicity criterion is not satisfied, not always satisfied for plurality with elimination. Now, what about the independence of irrelevant alternatives? Well, this fails in the same way as it fails with plurality. Namely, you could have a simple majority. You could have a case where you eliminate an irrelevant alternative, and because you've eliminated an irrelevant alternative, you've gained a simple majority by a minority candidate. The Math Club example should provide a case where you see that this also is not satisfied. But I'm not going to go through that again. So look back in the earlier video to see why that might be the case. All right, so for plurality with elimination method, we see again, like we saw with board account, that only one of those fairness criteria are always satisfied. Meaning maybe it's not the best method to use, or unless you really like majority as your top concern.